Hey guys, let's discuss new meta interview loop round, which is round 2, coding round 1, you can say. So here we will be discussing about very important problem, very famous problem from meta, which is alien dictionary. Okay, so alien dictionary is nothing. See, we know that in alphabet A comes before B. Yeah, before B, right? Or A comes before Z. So we know the order A, B, C, D. What is the order? Okay, now. The dictionary you have given is alien. Okay, you're not sure about the order. There B can come before A, okay, or Z can come before A. So the order is not defined there, and you need to find that order, that which word will come first and which word will come second. So you know, this kind of question we solve using the topological sort, right? In topological sort, you first you create a graph, okay, adjacency list, and then using that graph you count the in degree of each vertexes. Okay, how many incoming edges are there in the vertex, and then the vertex whose in degree is 0 you put into the queue. Okay, and then until the queue is not empty, you take that vertex, okay, and all the associated vertex from that or you can say node, um, we will reduce the in degree, right? And once the queue is empty, you just return the result. So this is very simple. Okay, so here let's say this is the question. Okay, WRT. Let me first dry run the question, then we will go with the step-by-step solution, like how you will answer this question. So this one, let's say the question you have given is WRT, okay, then WRF, after that ER, then ETT, and then RTFF. See here, if you see, W will come first, then E will come first, second, then R, then T, and then F. This is the order. Then this is the answer you have to given. How you will find this? So first you create the graph, okay, which one will come first. So for example, you will check I and I plus 1 element. Okay, when I is starting from 0 and I is less than the length of the this list, okay, the array. So now you can see here, see, can you check these two words, okay, and can you tell me which character is coming first? See, this one is W, this one is W, so we cannot determine because both are same. This one is R, this one is R, again we cannot determine. But here T is coming before F, so you are sure, right? T will come before F. This is so sure. T will come before F. So you can say something like this using topological sort. If there is an age from U to V, it means that U is coming before V, right? So T to F. Now can you let me write WRF, right? WRF. Okay, now can you compare I plus plus? So can you compare this WRF and ER, right? So this one is W and this one is E. It means W is coming before E. So you have W which is coming before E. Right now you don't know the link between these two, but you're sure that W is coming before E and T is coming before F. Okay, now from this one and this one, what you can determine? See, E is equivalent to E, so you cannot determine I plus plus. So now R is coming before T. Okay, do you have R or T? Yeah, R is coming before T. You will add that vertex there. Now from this ETT, okay, this is ETT and this is RTFF. So E is coming before R. So it means that the E is coming before R, right? And then ET, then T and T you cannot determine, and then again T and F. So it means T is coming before F, which is correct. T is coming before F. So graph will look like this. Okay, now can you calculate its in degree? So in degree of W will be 0 because no edges is going inside W. In degree of E is 1. Okay, in degree of R is again 1 because this one edge is coming from E. In degree of T is again 1, and in degree of F is again 1. Okay, now you will create one queue, and in that queue you will put the vertex whose in degree is 0. So here currently it is W, right? So I will put W. Now I will take out anything else? No. Now I will take out W, okay, and we'll add that in a result. So result equal to W, let's say. Now you don't have W here. So if you remove this W from the graph, okay, it means that all the adjacent vertices, okay, we have their in degree will reduce to 1, right? Because the existence of W is not there now. So this one will become 0. Now as this one is become 0, you can add this in the queue, right? So again you will take out E, from the queue, so its adjacent is this one will become 0. Okay, now you can add r in the queue again because its in degree became 0. So now you, when you will take out r, okay, this one will become 0, then you will put t, then you will take out this t, okay, then this one will become 0, then you will put f, and then f will come here. So w e r f t, this is the order in this alien dictionary. Okay, in our alphabet what happened, e comes first, e, f, and then remaining, okay, r, t, and w. But this is the alien dictionary order. So this is how you need to find, and this is very simple, right? If you see the Java program of this, the exactly same thing there we are doing. I'll explain you. So before that, let's start from starting. Okay, we will be discussing here two role answers. One is E5, second is E6. Okay, so expectation differ by level. Now what E5 senior software engineer will answer: write a correct and efficient solution using topological sort. So that is, we saw that, right? Then E6 staff engineer will discuss scalability, like what happen if this array you have given is in billions of millions or billions values are there, then scalability, how you will define. Okay, you will add the servers for the computation. Then streaming data, right now you know the value of n, okay, length of the array. Let's say you don't know the value of n, it is a streaming of data. First wrt is coming, then wrf, then er, and you have to process as it is coming. So how you will handle that streaming of data? Okay, then distributed graph, let's say this graph is very big, you cannot store that in one server, then how you will store that in multiple servers? Okay, then construction about the graph, and Unicode support, and production optimization. So he will be talking about all these things. Now problem statement we have already seen. Okay, you have given one input and you need to find the output, the order of the alphabets. If I will answer that I will model character as a nodes. We have seen that each character was a node for us, right? And by comparing adjacent words, I can determine character precedence and build a directed graph. We have done that. Okay, then I will use topological sort, Kahn's algorithm, to derive the character order. If a cycle exists, then dictionary is invalid. This thing you need to take care. If the cycle is there, then dictionary is invalid, right? A is coming before B, and B is coming before A. That is a deadlock, right? So if a cycle exists there, then invalid dictionary. Okay, now let's see Java solution using the Kahn's algorithm. Okay, so this is the alien order is your class, okay, main class, and you have given words array. You have different words there. Now you will create two map here. Okay, the first one is first we will create the graph, right? And then you will create one map for the in degree, where you will store in degree of each character, right? Now first you will do, you will iterate that words array, okay, and then you will for each word, okay, like you have a 7 word in the array. Now you will take one word, and it's each character. For each character you will put that in a graph, okay, and you will put the in degree to 0 also initially. Now again you will iterate that words at length array, okay, and then you will iterate first two words. We have seen that, right? First we were iterating this WRT and WRF 0 and 1, then 1 and 2 position, then 2 and 3 position, then 3 and 4th position. We have done that, right? That's why we have taken here j is starting from 0, okay, so j, and here I is starting from 0, so I and I plus 1. First you have taken W1 and W2, okay, word 1, word 2. Then you will check that, see, W1 length, let's say W1 is ABCD, okay, and W2 is ABC, right? So W1 is greater than W2, and W1 is start with W2, so it means there is nothing to compare, like this one AA is correct, BB is correct, CC is correct. How you will determine the order, okay? And D, with whom you will compare? You don't have anything. So this kind of case is you will return empty, okay, because W1 length is greater than W2, and W1 starts with W2. So this is starting from ABC. This one is also starting from ABC. Okay, so otherwise what you will do, you will first find the minimum length word, okay. Why minimum length? Because see, here you have 3 word only, so you will compare only 3. Now why to compare remaining one? With whom you will compare, right? So that's why math dot minimum, and then first you find the minimum, okay, and then for each character of that word you will check, okay, you will find the C1 and C2, and then if C1 C2 is not equal to, then you will and if graph C1 and if graph has C1 to C2 direction, okay, then what you will do, it's in degree, the actual in degree it will get C2, okay, plus 1. Why C2 and not C1? See, if there is a age from C1 to C2, then definitely you will calculate the in degree of C2 na, C2 equal to 1, not C1. Age is going from C1 to C2, that's why C2 is getting calculated. Otherwise, so you will add all the in degrees in the this array, okay, in this map. Now you will create, once you form the let's say you have formed complete graph and then you have calculated the in degree also, after that the queue part will come, okay. So in queue you will create one queue, you will whose in degree is 0, you will put all the value, queue dot offer means insert value in queue. After that you create one string builder for the answer, okay, until queue is not empty you need to run this, okay. Just get the current value from the queue and append that in the answer. Now just check it's all adjacent neighbors, okay, and puts its in degree -1, right, and if the in degree became 0, then again offer that character in a queue. And then at the end, if answer length is equal to in degree size, because all the nodes you have processed, right, there is no cycle, then just return whatever is in the answer, otherwise empty. Very simple, right? Complexity, so order v plus e. Time complexity, space is also v plus e, okay, where v is the unique character and e is character dependencies, ages. Now what E6 will answer, okay, so for production, so he will answer all these things. On top of that, for production I would still use topological sort, but I would also consider incremental graph updates, okay. Incremental graph updates means, let's say you have a very big graph and there is a changes from C1 to C2, you have changed it to C3 to C4, so you do not need to rebuild entire graph, just do the incremental changes, whatever has been changed right now, just change that much only, okay. And distributed graph construction, if it is very big, then how you will construct it using multiple servers. After that, Unicode support, memory efficient adjacency structure, and streaming dictionary updates. We have seen all these things. Now let's talk about few follow-up questions here. So the first one is detect invalid input. How you will detect invalid input? Let's say invalid input is like this. You have ABC and then AB, okay. So since the longer word appears before it's a prefix, the dictionary is invalid, so you will return empty. We have seen this thing here using this one, right. This one I have explained you, word 1, word 2. The same thing he is also talking. Now E6, how he will validate. So first one is prefix violation, okay, then duplicate ages, empty dictionary, null input, and invalid Unicode sequence. Follow-up 2 is related to cycle detection, how you will detect the cycle. If I will say, if the number of processed nodes is less than the number of unique characters, the cycle exists. We have seen that, okay. This one we are checking that only, okay. Then E6 will say that, for example, A is going to B, B is going to C, and C is going again to A, means there is a cycle, okay. No valid ordering exists. Return an empty string and log the invalid dependencies. Follow-up question 3 is multiple valid answers, okay. You can have multiple valid answers also. So if I will say that multiple topological orders may satisfy the constraint, any valid ordering is acceptable unless the problem specifies lexicographically ordering, okay. It should not be lexicographically ordering, until and unless it is fine. Now till then it is fine. Now E6 will say, if deterministic output is required, replace the queue with the priority queue. So the smallest available character is always processed first, so you will replace queue to priority queue, so that it will give you minimum priority 1 only first. Follow-up question 4 is BFS versus DFS, okay. We have seen here BFS only. So if I will say BFS means Kahn's algorithm, whatever we have used, okay, uses in degree, naturally detects cycle, easier to implement, okay. Now what we do in DFS, so uses recursion, and recursion stack to detect the cycles. Now what E6 will say, for production system, I generally prefer Kahn's algorithm because it's a iterative, avoid stack overflow on large graph and integrates well with distributed processing. Okay, now follow up question 5, large dictionaries. So how you will handle the large dictionaries? So if I will say the algorithm still runs in order v plus e, how much large it is, but the algorithm time complexity and space complexity will be order v plus e. Now what E6 will say, for millions of words, okay, so in like you have a stream inputs, you will use stream inputs there, then build a graph incrementally, partition processing across workers, okay, and then store graph efficiently. Follow up question 6 is streaming words. Okay, let's say you have a streaming words, one by one you're getting word, not in entire array, but one by one you're getting the words. Then if I will say that process new words as they arrive instead of rebuilding the graph. Okay, so E6 will say about the pipeline, like incoming words will go to incremental graph updates, and from there it will go to update in degree, and from there it will go to incremental topological sort. This minimizes recomputation. Now follow up question 7 is Unicode support. Okay, so what will happen in Unicode support? So if I will say that replace character with Unicode points or string tokens, E6 will say that use UTF-8 or UTF-16 aware processing and avoid assumptions about the alphabet size. Support multilingual character set without code changes. Okay, if you don't say about this, that is also fine if you're not sure about it. Now follow up question 8 is parallel graph construction. So if I will say that graph construction is usually sequential because adjacent words comparison matters. E6 will say that partition the dictionary into chunks. Each worker build a partial graph, okay, and then merge graph while deduplicating edges before performing the final topological sort. Follow up question 9 is related to memory optimization. Okay, so if I will say that use adjacency list instead of adjacency matrix, because in matrix though lots of sale will be 0, right? But in list you will use the node where there is a cycle, there is a age, sorry. E6 will say that optimize further with sparse graph representation, age deduplication, primitive collection, graph comparison, and lazy node creation. Now follow up question 10 is time complexity discussion. So we have already discussed for building a graph, the complexity will be order n into L. Okay, n is the number of words and L is the size of the words, particular word, and then topological sort, so its complexity will be order v plus n, v plus e, and overall how much it would be n into L, n into L plus v plus e. See, L plus v plus e to normal your capacity, and you're multiplying n, okay, with that. N is the number of words, L is the average word length, V is unique character, and E is character preceding ages. Now what E6 will say, the algorithm scales linearly with the size of the input graph. Since the number of unique characters is usually much smaller than the number of words, graph construction dominates the runtime for very large dictionaries. Okay, so that's it. Thank you.